All right, today we talked about dimensional analysis and the use of dimensionless groups. I'd like to just summarize three main points from lecture today. The first is the use of common dimensionless groups. I'll just say common groups here. We went through about 5 of those today. We had the coefficient of pressure, the Mach number, the Weber number. The two that I want to sort of reinforce here is the Reynolds number, which is a velocity scale times a length scale divided by the kinematic viscosity, which represents the ratio of the importance of accelerations or inertia to viscous forces. If the Reynolds number is very large, then viscous forces are unimportant. What we'll find is that the Reynolds number is sort of fundamental in a lot of descriptions of fluid flow. The other that I'll just quick review here is the Froude number, which is velocity divided by the square root of a gravitational acceleration in some length scale, frequently the depth of flow. This is the role of gravity, and so it's accelerations relative to the role of gravity. But what we're actually going to use this for is in open channel flow, the fluid speed over the wave speed. And that will have important it'll be an important determining factor in establishing the behavior of channel flow. Okay, so that's the first of the topics that I wanted to sort of revisit in this review. The second is the Buckingham-Pi theorem. And the Buckingham-Pi theorem tells us how many groups we need. So the Buckingham-Pi theorem says if we have k variables with m units, then we need k minus m dimensionless groups, or pi groups in the parlance of the theorem. How you get those groups is, it really doesn't matter as long as you end up with k minus m groups and include the set must include all variables. Once you reach that point, then you've got the necessary spanning set of dimensionless groups. Final point I'll make is that experiments and data can relate one group to the others. And that's the key thing in similitude, is to say that we're going to use these relationships to say that one dimensionless group is now a determined function of the other dimensionless group, so pi 2, pi 3, up to pi k minus m. And that function now becomes something that can be used to scale the results to the field scale if you're doing laboratory measurements, or simply to connect one system to another.